In this lesson, we will learn the definition of a real number, and we will examine some properties of real numbers. To begin, a real number is any number that can be shown on the number line. So the following numbers are examples of real numbers. Now, an important feature concerning real numbers is that with the exception of 0, all real numbers are either positive or negative. 0 itself is neither positive nor negative. Now, on the GRE, if a question involves an unknown value, we can assume that the value can be any real number unless we are told otherwise. Now, among the set of real numbers, there is one type of number that is of particular importance, and that is the integer. Integers are numbers such as 0, 1, 2, 3, and so on, as well as -1, -2, -3, and so on. Now, on the GRE, you will often encounter questions where you are specifically told that some unknown number is an integer, so you will know that the number must be from this set of values. Alright, let's return to the set of real numbers so we can examine some of their properties. To set up these properties, let's say that a, b, and c are real numbers. If this is the case, then our first property is a plus b must equal b plus a for all real numbers. In other words, when it comes to adding numbers, we can reverse the order of the numbers and the sum will remain the same. For example, 3 plus 8 gives us the same sum as 8 plus 3. We call this property the commutative property, but you don't need to memorize this for the GRE. Just know that when it comes to addition, we can reverse the order of the numbers and the sum does not change. Also know that some operations are commutative and some are not. For example, multiplication is commutative in that we can reverse the order of the numbers and the product remains the same. So, for example, the product of 2 times 5 is the same as the product of 5 times 2. The product is 10 in both cases. Now, subtraction, on the other hand, is not commutative. In this case, the order of the numbers does matter. For example, 4 minus 5 does not equal 5 minus 4. Now, please note that we are not saying that a minus b never equals b minus a. For example, if a and b both equal the same number, such as 5, then a minus b will indeed equal b minus a. All we are saying here is that it is not necessarily true that a minus b equals b minus a. In other words, subtraction is not commutative for every pair of numbers. Similarly, division is not commutative for every pair of numbers. For example, 6 divided by 2 is not equal to 2 divided by 6. Now, the next property says that the sum of a and b plus c is the same as a plus the sum of b and c. So, for example, if we want to find the sum of 1, 4, and 7, finding the sum of 1 and 4 first, and then adding 7, produces the same results as adding 1 to the sum of 4 and 7. The property demonstrated here is called the associative property, and we say that an operation is associative if changing the grouping, or brackets, does not change the results. Given this definition, we can see that multiplication is also associative. For example, if we take the product of 2 and 3 and then multiply that by 4, the result is the same as multiplying 2 by the product of 3 and 4. Now, subtraction, on the other hand, is not associative since changing the brackets changes the results. The following example demonstrates this. Similarly, division is not associative as is demonstrated in this example. Now, the next property is called the distributive property, which is illustrated by this example. This property says that the product of a number and a sum is equal to the sum of the individual products. In other words, a times the sum of b and c is equal to the product a times b plus the product a times c. The following example demonstrates this. 3 times 8 plus 2 is equal to 3 times 8 plus 3 times 2. Now, please note that the distributive property also works when the numbers in the brackets are being subtracted. For example, 10 times 7 minus 3 is equal to 10 times 7 minus 10 times 3. Now, the last set of properties concern the numbers 1 and 0. First, when we multiply any number by 1, the product is always that number. Second, when we divide any number by 1, the quotient is always that number. Next, whenever we multiply a number by 0, the product is always 0. And whenever we add 0 to a number, the sum is always that number. Finally, any non-zero number divided by itself is always equal to 1. In an upcoming lesson, we will examine what happens when we divide 0 by itself. Okay, let's summarize. In this lesson, we learned the definition of a real number, and we learned some important properties of real numbers.